This is Lecture 2 for Chapter 5. Now that we know more about our measures of center, we can now focus on distributions or models. The first is symmetric, sometimes known as a bell curve. What happens with a model that is symmetric, we have the mean, or the arithmetic average, the median, as well as the mode, all falling at the same location in the center. When we have a distribution that is skewed right, has the peak and then it has a tail on the right-hand side. And if you recall, mode is the most, so that would be the peak. Median is the middle. So when I start plucking off data one for one, it's going to end a little bit on this side. But if you take a look at what this tail means, it means I have extreme observations on the right, bigger observations on the right, which is going to take that mean and it's going to pull it to the right. So my mean, and this is exaggerated, but my mean is going to be pulled to the right because of these extreme values. By pulling it to the right, these extreme values make my mean bigger than it should be, i.e. pulling it to the right. When we have something that's called skewed left, the tail is on the left-hand side for the same reason as when it was skewed right. The extreme values are on the left, so it pulls the mean to the left, where again the peak would be the mode, and the middle here would be the median. So that's why our distributions look and are named as such. One thing we also want to study when we look at measurements, besides the measure of center and what the distribution looks like within these measures, we also like to study variation. Variation is what creates a uniqueness or an interest in data. If we had all data being the same value, we wouldn't have any interest in it. Variation means data is different. How much do they vary from each other? A simple measure of variation is the range. And the range is just such as that, the temperature range. And how you find that is it's the largest value in the data set minus the smallest. And this isn't very useful for most analysis. Really, it's useful when we talk about weather, the temperature range. So if I was to find the range, I would take the largest data value, 54, and subtract the smallest, which is 17, which is equal to 37. So I have a range of 37 data values between 57 and 17. There's 37 units between these values. Another way, and not a very useful way either to look at variation, is a 5-number summary. Most often this is used when we want to compare data sets. It's a great way to make a picture and compare the measures of center and so forth. Another name for the 5-number summary is called a box plot. And it's called a box plot because actually it's made from boxes. So what it looks like is this. You have this what sometimes is known as the whisker. There's your box, and then you have another line with an end. Now the length of these whiskers and the length of the box depends upon your data. So we have some working left to right, some values that we look at. The first one is a minimum. That would be the smallest. The next one we're going to look at is this line, which is what we call Q1, or quartile 1. And what it is the median of the lower half of the data. The third value is the one that really sits in here, which is drawn in that box. That is called, we could call it Q2. Recall the first one was called Q1, which would really just be the median. And so that's what we refer to it as. And that is obviously the middle. The next line that we're going to look at is on the end here, this green one, which we're going to call quartile 3. And that's the median of the upper half of the data. And then lastly, we have this line on the end, which would be the maximum, or the largest value in the data set. Now when we look at this, we can somewhat tell about skewness. And how we can do that is look to see in the box where the median line would be at. So if it's on this end, we would say that it is skewed left. Lots of times people want to look and say that a box like this is symmetric, but really you're not able to tell the distribution very well, especially not if it's symmetric. So we oftentimes don't look at a box plot for the distribution. We really like to look at the histogram and stem and leaf if we're looking for that distribution, whether it's skewed left or right. And the last thing is with the box plot, you can see outliers. So if this is my box, my median, my max, and my min, if I have a dot out here, that would be considered to be an outlier. And in order to be an outlier, you need to be 1.5 times the interquartile range. And the interquartile range is Q3 minus Q1.